Now, given that this expression here is positive, so we ought to use the equation as a graph above the x-axis because it's positive. So this is a quadratic, but we are not trying to solve the x. Okay, since it says it's positive, so there will not be any x because the graph will look like this. So positive x squared, but it's above the x-axis because it's all positive, and there's no solution. There's no x-intercept, so no solutions means that the discriminant of this expression would be less than 0. So for all real x, given that this expression is positive, we can say that discriminant of the same expression will be less than 0. So taking the discriminant out, so b squared minus 4, you see b squared minus 4 a c. So bringing this 8k term over, so we have 8k greater than 25. We have found the range of k, so the range of k would just be greater than 25 over 8. Now, next part requires us to solve this inequality. So we need to find out that whatever we have done for the first part is actually for us to observe this numerator in the second part that we are trying to solve. So we just say we compare the numerator that we have over here with the expression that is given in the first part of the question. We can see that k equals to 4, which is also greater than the 25 over 8. So this implies that the numerator would be as given in the condition, positive. So we have shown that the numerator is positive. Just put for all real x. So if the numerator is positive and the denominator over here, it gives us an overall fraction that this is actually negative. So it will imply that the denominator itself is negative, because a fraction like this will be positive over negative. That's why the overall fraction is negative. So we can straightaway imply the denominator is negative. So we try to solve this. We can factorize the expression here first. Now it's a 3x squared minus 16x plus 5, so we factorize it. And we can draw the curve of this expression, solving at x as 1/3, so one of the root will be 1 over 3 and the other will be 5. So 1 over 3 and 5. So the required range is at the y values that give us a negative, so we look below the x-axis. So below the x-axis is actually this portion here. So this portion here is between the range of x from between 1/3 and 5. So we can just simply conclude the range of x, okay, for the second part that we require us to solve is between 1/3 and 5.